Hello everyone, welcome to new class. Today's class is about the properties of determinants. So in the previous classes we have discussed about the determinants, that is how to find the determinant of orders 1, 2, 3 and 4. Next is properties of determinants. First one is the value of determinant remain unchanged if its rows and columns are interchanged. For example, delta is equal to determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. So, the first property is if we interchange the rows and columns, then the value of determinant is not changed. That is, let delta 1 is equal to, let us change the rows into columns. That is A1, A2, A3. That is first row we changed into first column. Then second row into second column. Third row into third column. Determinant of. Then the value of determinant remain unchanged. That is the delta of this one and the delta 1 of this one will be equal. That is delta is equal to delta 1. That is if we change or if we interchange the rows into columns, then the value of determinant is not changed. Or we can say that let A is a square matrix, then determinant of A is equal to determinant of A transpose, A dash or A T. So, if we change the rows into columns, then we get the transpose of that matrix. So, we can say that determinant of a matrix is equal to determinant of that matrix transpose. So, we can write determinant of A is equal to determinant of A transpose. Second property is if any two rows or columns of a determinant are interchanged, then sign of determinant changes. That is like delta is equal to determinant of A1, A2, A3, B1, B2, B3, then C1, C2, C3. Then if we change any two rows, that is interchange these two rows or these two rows like or interchange any two columns, then sign of that determinant changes, not the value, only sign changes. That is let delta 1 is equal to, let us interchange these two rows. So here we will get C1, C2, C3. Then second row no change, B1, B2, B3. So the first row becomes the third row. So A1, A2, A3 determinant of. Then in this case delta will be equal to minus of delta 1. That is the value of determinant not change but its sign changes. So if any two rows or any two columns of a determinant are interchanged, then sign of that determinant changes. Next property is if any two rows or columns of a determinant are identical, that is all corresponding elements are same, then value of determinant is 0. For example, if delta is equal to determinant of 3, 2, 3, 2, 2, 3, 3, 2, 3, that is here the first row and the second row are identical. So all the elements, corresponding elements are same here. Then here the delta will be equal to 0. So let us check that. Let us find the determinant. That is 3 into 6 minus 6. Then minus 2 into then 6 minus 9. Then plus 3 into 4 minus 6. that is equal to, here we will get 0, then here minus 3 into 2, that is plus 6, then here minus 2 into 3, that is minus 6, that is equal to 0. So, if any two rows or columns of a determinant are identical, then the value of determinant is 0. Then fourth property, if each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. So, if any one row or any one column of a determinant is multiplied by constant k, then its value gets multiplied by that constant k. So, let delta is equal to A1 B1 C1, A2 B2 C2, A3 B3 C3. Then let delta 1 is equal to, let us multiply the first row with constant k. Then we will get determinant of k into A1, k into B1, k into C1. Then remaining no change, A2, B2, C2, A3, B3, C3. Then what will be the value? So here for this delta there is one value, and for this delta 1 will be equal to k multiplied with the value of this determinant, that is delta 1 here will be equal to this k times the value of determinant of this one. So delta 1 will be equal to k into delta, because from here we can take this k outside, that is k into, we can write like this k into A1 B1 C1, A2 B2 C2, A3 B3 C3. So here the value of this determinant will be multiplied by the value of this determinant by k. And by this property we can take out any common factor from any one row or any one column of a given determinant. For example, if delta is equal to A1 B1 C1, A2 B2 C2, A3 B3 C3, then if we multiply this column and this column, that is the second column and third column with the value k, then we can take out 1k, that is from this column we can take out 1k, and from this column we can take out 1k. Then we will get the remaining determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. So here we will get k square times this value. Similarly, after taking out such constants from other rows or columns, then if any two rows or columns becomes the same, that is identical, then its value will be 0. That is, for example, let delta is equal to A1 B1 C1, K A2, K B2, K C2, A2 B2 C2. So in this case we can take this k outside. So k into A1 B1 C1. Here we will get A2 B2 C2, and this row also A2 B2 C2. So here we will get, here these two rows are identical. So this is the third property. So by the third property its value is 0, because if any two rows or any two columns are identical, then the value of determinant will be 0. So its value will be equal to 0 in this case. Next property is, if some or all elements of a row or column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. That is, for example, the determinant of A1 plus delta 1, E2 plus delta 2, A3 plus delta 3, B1, B2, B3, C1, C2, C3 can be expressed as the sum of, so here the first row is expressed as sum of two terms. So this can be expressed as the sum of two determinants. That is, we can split this one like this. That is A1, B1, C1, A2, B2, C2, A3, B3, C3 plus determinant of delta 1, B1, C1, delta 2, B2, C2, delta 3, B3, C3. So we can express the determinants like this also. Next property is, if to each element of any row or column of a determinant, the equimultiples of corresponding elements of other row or column are added, then the value of determinant remains the same. That is, the value of determinant remains same if we apply the operation Ri implies Ri plus K into Rj, or Ci implies Ci plus K into Cj. For example, if delta is equal to determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3 and delta 1 is equal to A1 plus K C1, A2 plus K C2, A3 plus K C3, B1, B2, B3, C1, C2, C3. So here this delta 1 is obtained by the operation R1 implies R1 plus K into R3. So here we have multiplied the elements of the third row by a constant and added them to the corresponding elements of the first row. That is this operation. And here, what is the property? If we add like this, then the determinant value will not change. So let us check that. So here delta 1 can be written like this. That is, here we can split this one. That is, by the property 5 we can split this one, that is A1, B1, C1 like that. So determinant of A1, B1, C1, then A2, B2, C2, then A3, B3, C3 plus, here we can write K C1, B1, C1, then K C2, B2, C2, K C3, B3, C3. So here we can find that this K is constant in this row. So we can take this K outside. Then we will get this first row and the third row identical. So here C1, C2, C3 and here also C1, C2, C3. So what will be the value of this determinant? So its value will be equal to 0. So here we will get the value of this determinant only, and that is equal to this delta. That is, here we will get delta plus 0, that is delta itself. So this is the sixth property. So that is about the properties of determinants. So in the next class, let us do the problems related to these properties of determinants. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.